Alright, today we're doing the Oxford Mathematics Admissions Test Problem H. I'm trying to do the problems like concurrently, so I'll make a video from G and then I'll make a video about H. And yeah. Anyways, let's get right into it. So consider two functions, f of x equals a minus x squared and g of x equals x to the fourth minus a. For precisely which values of a greater than 0 is the area of the region bounded by the x-axis and the curve y equals f of x bigger than the area of the region bounded by the x-axis and the curve y equals g of x? Okay, so let's try and graph this to kind of get a good picture of what's going on. You have a minus x squared, so it's going to be some quantity like this, and then the roots will be root a, sorry, not root a, should be negative root a, right? Okay, let me just kind of extend that line. That's more sensible. Negative root a, and this will be positive root a here. That's one graph, and we want to find basically this shaded region here. Okay. And then we have another graph, something like this. Sorry about that. Something like this. I'm going to try my best to draw this. And then we have a minimum, so we're going to have something like this. Not so accurate, but not a big deal. This quantity here will be negative root a, or negative the fourth root of a, because if you do the calculations, you'll find that's the root. And this quantity here will be the fourth root of a. Okay, so we want to find basically this quantity. And then we want to figure out when is f of x greater than g of x, right? And I'll kind of put them in yellow so we know that we're referring to the yellow quantities. I'll kind of like mark it out like this, right? Kind of not like that. I'll just put it in yellow like this. We're not referring about the yellow portions. Okay, let's get right into it. So how can we solve this? Obviously, we can use elementary calculus to solve it, and let's just do that real quick. So we can basically integrate, negative root a to root a of a minus x squared dx, and let's just do this real quick. Okay, so that's just a derivative, and we can now solve it. Just plug in negative root a to get, let's just plug in root a to get. Let's think about how can I do this. So I'll get a to the 3 over 2 here, and then I'll get a to the 3 over 2 out of 3, and then that's the first quantity, and then I'm going to subtract and plug in negative root a. I'm going to get, what quantity? I'm going to get minus negative a to the 3 over 2. Plus, we're going to plug in a to the 3 over 2, and plus a to the 3 out of 2 over 3. So this is basically like 1 minus 1/3, and it's the same thing as like minusing 1 minus 1/3. Or basically, it's minusing, just adding 2/3 again. So it's basically 4/3 a to 3 to 2. 4/3 a to 3 out of 2. And this is equal to f. Okay. I don't know why this is going down. Anyways, that's f of x. That region, I'm referring to the yellow region, obviously. Okay, I'm trying to break this down slowly so you guys can understand what I'm doing. And then we can do the other, I don't know why that, okay. Let's do the other derivative. So let's say the derivative. I'm actually horrible at drawing derivative signs. negative root a to the fourth and fourth root of a. So basically, we're going to take x. So let's just write that in derivative form. And plug in the values to get. Let's see if I plug in negative root a to the fourth, I'll get a to the 5 over 4 over 5 minus, let's see, that's going to be a to the 5 out of 4. That's one quantity. And then the other quantity will be mine. We're going to subtract when you plug in the negative quantity. So we plug the negative quantity to this value. Let me just try to do it in my head. See what we're looking at. So that's going to be that. And then you plug that in. We're going to get, let's see, negative a to the 5 over 4 on the top out of 5. And then we're going to add, because they're negative negatives, we're going to add a to the 5 over 4. So these two quantities, what is the sum? The sum would be, not sum, rather subtraction, but the difference would be negative 8 out of 5, a to the 5 out of 4. Thing is, we're looking at a quantity that's below the x-axis, as you can see. That's this quantity here. But so that's just basically positive version. That's just 8 to the 5. So basically, one is, let me kind of put it here. So one is greater than, what was it? 8 out of negative, what was it? Negative 8 out of 5, right? Sorry about that. 8 out of 5 to the a to the 5 out of 4, correct? And now we can, we know that a to the 5 out of 4 is obviously a positive quantity because it tells us that a is greater than 0. So we can divide by this, and okay. So we can basically multiply, we can basically multiply by 20 over 3. We can get 20 over 3, and we can add 3, so we get basically 20 a to the 3 out of 2 is greater than 24 to the a out of 5 out of 4. So let's think about this. We can divide by a to the 5 out of both sides to get 28 to the 1 out of 4. So less than 24. And then we can basically divide by 24 to get a, or not, sorry, not divide by 20. Oh, sorry about that. Oh gosh, a to the 1 out of 4 is equal to 24 out of 20, which is the same thing as 6 out of 5. Correct, yeah, 6 out of 5. And then we can do the fourth root of that to get a equals this quantity here. You get a equals this quantity here. And let's see what answer choice that is. And look, or not a, but it's going to be greater. Sorry, I don't know why I said equals. Anyways, that's going to be answer choice E. We're done.